So I know it's been a long time between videos, but today I've got a topic that I'm excited enough to talk about, that I've got the camera back out, and that topic is 3D printing car parts. I've been printing like a madman for the last 9 months for a whole bunch of projects on the Drift E46 behind me. In particular, this intake pipe, which is hopefully in frame, that I've done for the Supercharged LS. It's been a big project to do. I've learnt so much. And what I'm hoping to do with this video is basically do a quick start guide for anyone that's not really into 3D printing that much at the moment, so they get a bit of an idea of the steps that you need to take, the processes you need to learn to make their own car parts. So that is going to be what today's video is all about. It's not going to be an in-depth tutorial. I'm not going to teach you how to use CAD. There is enough tutorials out there that can go into the details of that. But I sort of want to get the workflow out there so people realize that you don't need that much crazy equipment to do this. You don't need a crazy amount of skill. Most people can do this. Yeah, some of the printers are going to be a couple of $1,000s, but that's the main barrier to entry. And then you can make parts like this intake behind me, or I've also got a bonnet scoop that I've made recently. So that's going to be today's video. Let's get cracking. Well, first things first, let's take a look at the projects that I've done with 3D printing thus far, just to give you an idea of what you can do. And the first major project that I did was the shifter surround. So I had a big gaping hole there before, wasn't exactly safe, and I had to get that closed up. So what I did was I scanned the trans tunnel. I bought a boot from S1 Sequential, which is this shifter that sits on top of the T56, and then I 3D printed this surround that holds the rubber down and seals everything up. Really happy with how that came out. That's out of a filament called PAHT. And then the same filament I used on this bonnet scoop here, or technically a bonnet bulge. So this is to cover up the hole from the supercharger where that sticks out. And it's actually made up of 4 pieces. You can see the glue that I've used in the middle to stick it all together, and got to do a bit of bodywork on that to make it look nice, but again, this is used probably about 6 or 7 days of drifting now with no issues, and I've been really happy with it. Then finally, with the bonnet up, we can see the biggest project thus far, and the one that we're going to delve into today, and that is the intake system here. So this is out of PPCF, and it's bloody strong, very heat resistant, and also quite oil and fuel resistant. So that's part of the reason that we chose it. You can see here it bolts straight onto the throttle body. It's a Motion Raceworks throttle body. Works its way without hitting anything here with the radiators or with the tensioner, down into another piece, the lower section that goes under the car. Ignore the wiring I've got to clean up there. Finally, in the front bar you can see the pod filter, and we've also got a splash guard just to protect from any water coming off the wheels. And that is a basic breakdown of the intake system there. But obviously, like most things, it's not hugely complicated to look at the end product, but how you got there, well, that's a whole other story. Now that you've seen the final parts, let's jump back to the start, and we're going to go step by step on how we got there. So the first thing we need to think about is measurements. We need to know, how big can this part that we're building be? Where are we mounting it to the car? And is it going to protrude or hit other items that are mounted in the car? So to do that, there's 2 different ways. You can get old school, you get your verniers out, you do a whole bunch of measurements, write them down, bring them back to the computer and put them into CAD manually and start building your part that way. Now this is probably the best way of going about it, particularly if you're new to 3D printing and CAD, or if the part that you're building is pretty simple. Something like this roll bar mount, you can do a couple of measurements and have that drawn up in CAD in a matter of 5 minutes. However, once you get down the track and you start doing more complex parts that are tighter tolerances, there's more things around them, then you're probably going to want to move to 3D scanning. This is my 3D scanner here, cost about $500. It's a Creality Ferret. It's a pretty basic unit, but for what I need to do, it seems to do the job pretty well. And I can use that scan data, enter it into CAD, and then start building my part that way and be able to build it in real time, seeing if it's going to hit items or where I'm going to mount everything from. So it's a really good way of doing more complex stuff, but I probably wouldn't recommend it if you're just starting out with your 3D printer at the moment. Leave that for a little bit later on. However, in this case, we did use it, and I think I'm just going to go jump outside and we'll do a quick scan to show you how it works. So it's all a pretty simple process. At the moment, it's picking up the intake pipe. If I go over here, you'll probably see the supercharger pulley. So we're in the right range at the moment. We'll start this scan and see how we go. So as we build up, the green, the bright green is, that's the areas that it's seeing at the moment. We can see the data that's left behind. The red areas need more information. The green areas have a fair bit. So we've got to focus on the red. We want to make sure that we're moving this around from different perspectives. We're not just all coming from the same angle. Otherwise, it's only going to see one side of everything that we're doing. We'll move our way around this side, start to get some of the supercharger pulley. And this isn't going too bad. So I'll cut to a time lapse and we'll build up all this data. So the scan's all done. It's come up looking pretty good. Couldn't go too big on this one because the computer was starting to struggle. But now we've got all those individual data points in there. The system is going to be able to process them into a mesh. We're just going to go with the basic one-click express mesh here. And that is going to process all of that into data that we can input into Fusion 360. So now that we've got our scan and we've processed it through the scanning software, we need to import it into Fusion 360. This is the scan that I did of the front of the E46. It's got all the information that we need on it. We've got our radiator support, radiator shroud, throttle body, chassis rail, and the back of the headlight, which is all of the information that we're going to need. And before we can really start working off this, we need to do a little bit of processing to it. You can delete a lot of this junk off the front here that you don't need. It does make everything a lot more smooth for the computer to process. At the time, I didn't know that was a thing. So I just took the raw scan data and started using that. To actually use the data, we need to build some construction planes off it. To do that, we've got to go to Modify, Direct Edit, and then we end up building construction planes using plane through 3 points. Basically, we just select 3 points on the scan itself, and it'll give us a construction plane. And that construction plane is what you start building sketches off of. So if you haven't really used CAD before, you're probably going to need to learn some of the basic stuff because there's a lot to learn. It's probably the hardest part of doing your own 3D printed car parts is learning the CAD software. So now that we've got our construction planes, and you can see there's a bunch here, in particular going behind the headlight because we had to be very particular about how we designed that. And then we've also got one in the middle of the throttle body here that created a plane for us to start that top pipe. Then from planes, we go to sketches, and these are all the sketches that I used. You can see the flange here had a lot of intricate designs to match up to the throttle body design. And then you've got a lot of planes going through, again, behind the headlight to make sure that we've got the right sizing so that we don't hit the car, but we also maximize our airflow. From those sketches, we created the actual pipes, mostly using the Lofton pipe tool. And you can see that they've come out pretty good. There's a bunch of different work in here too to smooth everything out. And having a look down here, you can see the mounting points for this. We've got one here to the chassis, which is actually not the chassis, that's the wheel well. And then one that does go to the chassis rail there. You can't actually see that mounting hole on the scan. It's something that was missed in the scan because it's way down in the bottom there. So we had to get the calipers out and actually measure that by hand. But yeah, that's all the mounting points for the lower section. Then up top, obviously we're bolting that onto the throttle body and then doing a design that doesn't hit any of the radiator shrouds, the bonnet, or the tensioner for the drive system there. So yeah, a lot of time involved in learning how to do this. This is probably 4 or 5 months of learning for me to get to the end stage of having these parts. Even got a bit fancy towards the end, did a bunch of hexagons on the pipe, as well as one arm bandit. Had a couple of issues because the CAD and the real world didn't quite line up. You can see here that the two pipes actually don't aim directly at each other. And that is because the plane that I did off the throttle body isn't perfectly flat to the same plane in the real world. And so when that's only off by a little bit on its angle, it actually meant that when you bolted it on, the end point for this pipe was in a different spot to the real world. So had to adjust the CAD to make up for that. But overall, was a process that I learnt a lot. I, towards the end, had such a timeline, which is this down the bottom here, that's so big that it became problematic for the computer to process, and I discovered about components. And so the last piece here, which is the splash guard, that was designed as a different component, and yeah, that was just a part of the learning process. So now that we had all of that designed, we could export it to the Bambu Lab software. How we do that is we go right click, save as mesh, and then STL and millimeter, and we export it out, and then we're going to import it to the Bambu Lab software. This Fusion 360, it's for personal use, i.e. no commercial use. You can actually download this for free. Anyway, that is the CAD side of things done. Now we'll jump over to the Bambu Lab software and look at how we actually print it with the printing software. So we're now in Bambu Lab Studios. We've got our lower intake pipe on the screen with our bed. There's a few things that we want to think about, and I'm not going to do a deep dive into this software again because there's hundreds of tutorials out there. I'm just going to go through a couple of bits and pieces that I specifically thought about and were more relevant to car parts. And that is, firstly, what filament are we going to use? In this case, there's 3 factors I needed to think about. One of them was the strength. We need it to be nice and strong. Obviously, this is going to be in front of a supercharged LS, so there's a bit of suction there. Also, if this does fail and bits end up going through the supercharger and the engine, that's not going to be good. So we want to make sure we've got a good margin for error. And then we've got to think about heat. Particularly the top pipe is going to be on top of the radiator, so all that radiant heat is going to be hitting the pipe for a long period of time. And then lastly, it's going to be in an engine bay, so it's got to be resistant, at least on the short term, to oils and fuels. So what we're going to do is we're going to go with PPS-CF. The reason being, it's quite expensive. It's probably the second most expensive filament that the Bambu Lab printer can print, but it is also the second strongest. It is the most resistant to heat that the Bambu Lab printer can print. Deflection temperature is about 250 degrees Celsius, which is pretty high, and probably about 100 degrees higher than it's actually going to see in the car. And then lastly, it's going to be an engine bay, so it's going to get oil residue and fuel hitting it occasionally, and we need to make sure that it's going to be able to hold up, not degrade when it's touching any of those chemicals. So those 3 are the reason why that it came out on top. So next thing we've got to think about is things like strength. How many walls do we do? In this case, we had 3. And what kind of infill do we do? Infill is basically the amount of air, percentage of air inside the part, because you're able to do printing in a way where there's a bunch of air pockets inside it, meaning you don't need as much filament. It's not as long to print. However, in this case, we want something nice and strong, so we have got 100% infill. Most parts you probably get away with 30 or 40%, but in this case, I'm not taking any chances. I'd rather spend the extra time and spend the extra bit on filament to get it as strong as possible. And then we've got to think about our supports, and this comes back also to our design. If we have bits that stick out at 90 degrees, then we're going to have to put supports in to support it. And in this case, I do actually have one of them here. So we're going to need supports to hold that up, because 3D printing goes layer by layer. If there's not a layer underneath it, it's just going to droop and hang. So we have supports all set up here. And we're also got to think about orientation. In this case, we're printing it so strong that it's not so much of an issue, but everything that goes vertically on the build plate isn't going to be as strong as if they went along the build plate in this direction. So if you have something that is printed upwards that's really thin, it's not going to be very strong compared to if you run it across the build plate like that. In this case, we are just trying to fit this pipe inside the build plate because it's so big, and we've got 100% infill, reasonably thick walls, so we're going to be fine for strength, but it is something to think about depending on how you design your part. So with all that considered, we end up slicing the plate. Slicing is basically the computer going through and taking all your settings and converting them to G code, which is the code that the printer uses to build the part. It thinks about things like, where's the support going to go? Where do I start and stop each of the layers? All sorts of stuff that I don't 100% understand. But either way, the software knows what it's doing, and it has put together all the G code that we need to get this printed. We're going to be using 510 grams. 45 is going to be used in support, so we're going to use that in total. It's going to take us just over a day to print it, and we can use the slider here to look at how that printing is going to happen. And also if we go like this, we can see where the print head is going to be, a little grey line. And also got all the G code there, so there is a lot. That is just one layer's worth of G code that I'm going through right now. So after we're all happy with that, we go print plate. And this will send the information via the internet usually. I'm not sure if there's an option where you can plug a cable in, but I use the cloud-based software, and it'll go through, it'll send that G-code file to the printer and start printing it. In this case, it knows that I've not got the right filament loaded because it needs some specific setup on the printer to be done for this filament because it's so brittle. You can choose your time lapses or whatever you need to and then send it off. I can actually use this being cloud-based from home, so as long as there's nothing on the print bed already, I can hit print and it'll start printing from home. From work, I can check on it on my phone. They've got a camera inside the printer that you can check on the build as it's happening from wherever I am with my phone. So it's a cool bit of kit. Once we hit send, it'll then start warming up the build plate, warming up the bed, and printing. So while we watch the printer do its thing, let's talk about the printer itself. I ended up buying a H2S Bambu Labs product. After years of having the Ender 3 and having non-stop problems trying to get that to print, there was a couple of things that ended up being the important factors that made me get this printer. Firstly, the big bed size. Bambu Lab had some smaller printers, 256 mil cubed, for a little while, but I never felt that they were big enough to do the car parts I wanted. So when they come along with this one, which is about 320 mil cubed, then I felt that that was enough to justify me buying it. Secondly, I wanted it to be reliable. I wanted to be able to just set this thing to print and I'd come back at the end of the day with a really high chance of being able to have a finished product. And that's pretty much what I've got. That's what everyone said about Bambu Lab. And lastly, I wanted to be able to print those nylons, those engineering grade materials, which this unit can do with the heat that it gets with its nozzle at 350 degrees. So it ticked all three of the boxes, but obviously this is my experience. You do your research if you're in the market for a printer and buy what you're comfortable with, but I gotta say, I've been really happy with it. So if you've made it this far into the video, I think you're becoming a 3D printing nerd because it's pretty nerdy to make it this far, to be honest. So there's a couple of post and pre-processing that we need to think about with the 3D printing stuff now, and it's a bit nerdy, so we'll get into the details of it, and that is you need to dry out the filament. Filament is hygroscopic, so over time you'll get water essentially coming out of the atmosphere into the filament, and that doesn't do very well for 3D printing. So what we're going to think about is drying the filament before we put it into the printer. Now you're going to get away with this with some of the more basic filaments. Things like PLA and PETG are going to be pretty much fine, just printing straight off the roll, or even if you just left a roll out like I do, you're going to be pretty good just straight off the rip to print those. However, when you get to ABS and ASA, that is going to be a bit more of a problem. You'll get a bunch of stringing if you haven't dried your filament properly. And honestly, it just gets worse from there, up to the stage of the nylons where you need to bake the crap out of them for them to actually print pretty well. So a couple of different ways you can go about doing that. Firstly, you can get a filament dryer like the AMS2 Pro. That is a ripper unit. If you get a Bambu Lab, or even if you get a Creality, I think they've got a version of the AMS, make sure you get it. It's basically an auto feeder for the printer, and it makes your life a bunch easier. But they also have heating functions, so they can heat the chamber up to 65 degrees and let you pretty much stay at that temperature for as long as you need to dry the filament. That's good for ABS, ASA, even PAHT. I've dried in that before and had good results. If you're going to get a little bit more hardcore than that with the engineering filaments, I would recommend buying one of these. That is just a regular ass oven. But not just any oven, it is a $50 marketplace special. So what I do with this is I've got a big pizza stone in there to help regulate the temperature. I've got a separate thermometer to make sure that the temperature on the oven is actually correct. And I can put the PPS CF in there, bake it at 130 degrees for 12 hours, and that comes up pretty good. That's what I've done with all of the PPS that I've had thus far. Haven't run into any issues. So it's probably not the professional way. I'm sure there's a better way of doing it than that, but for 50 bucks, it's worked out pretty good. So got to think about drying the filament. And then on the other end, for particularly the nylons, you want to think about annealing them. So annealing, it's a bit hard to describe and I don't truly understand it, but from what I understand, the crystals that are in 3D print, if you put them in an oven at the right temperature for the right amount of time, they essentially become one or become more of one, and they become stronger, they become more heat resistant. And again, I just put them in the oven to do that. So $50 oven on Marketplace, that is the ticket. The last thing I'm going to talk about is the different filaments. There is a lot of filaments. There is a sea of filaments. There is a never-ending supply of different filaments. So there is no right or wrong answer with what filament you should use, and there is not a go-to filament that you would use just one. There's probably about 4 or 5 that I have, and that is the hard part, is you've got to learn the differences between them, and there is quite a lot. So give you a little bit of a rundown of stuff that I use. I use PLA for prototyping. I use ABS and ASA if I'm going to be making a standard plastic part that I can put in any place that I could put normal plastic. I might use ASA if I'm going to be putting it out in the sun because that's a bit more UV resistant. Then next I've got my PAHT, which is like the base nylon that I used for the shifter surround and for the bonnet. And that's pretty good. I think it's up to about 150 degrees deflection temperature. It's pretty strong. That does need annealing, or it should have annealing. You can get away without it if you really want. And then finally at the top, there's the PPS. So that is the general layout of filaments, but there's a lot out there. So you want to do a bit of research and figure out which one is going to be right for you for the specific scenario. But yeah, that's a lot of information. I think that's more than enough for you to take in. Hopefully this has been just the first little bit to get you going and investigating printing your own 3D printed car parts. And yeah, there's a sea of tutorials out there, everything from CAD to 3D printing to 3D scanning. There is a tutorial to help you. You've just got to find the right one. So yeah, any questions, feel free to hit me up. I'm happy to have a chat about it. And yeah, I'll see you next time I feel like picking up the camera and recording something. Cheers.